Good morning, everyone. I am Samyak from Mechanical Regular. Today, we will be learning about ideal and practical sources. There is an ideal voltage source and an ideal current source. There's a practical voltage and a practical current source. First, let us compare the voltage sources. Whenever we talk about voltage sources, there are two things that we need to keep in mind. The first one is that the source resistance is always present in series connection for voltage sources. Second thing that we need to remember is that the value of source resistance in an ideal source is always zero. When we talk about an ideal source, we mean a perfect source that can give an output of what the voltage produced at source is. Hence, we can say that V out is equal to Vs, that is, output voltage is equal to the source voltage. This is because the resistance provided by the source is zero. That is why there is no voltage loss occurring in this area, and hence the output that we get is always equal to the source voltage. Looking at the graph of an ideal voltage source, you can see that as time passes, the voltage is constant and the output voltage is equal to the supply source voltage throughout at every point of time. Coming to practical voltage source, you can see in the graph that there is a dip. This dip in the graph from the ideal level till this level is because the source resistance is not zero. In a practical scenario, the source resistance cannot be zero and it can be considered to be minimum. So Rs is equal to R minimum. Now, hence, there is a value for source resistance. Because it has a value, there will be a slight voltage drop, which can be represented by Is into Rs, which is the current flowing into the source resistance, and multiplied by the value of resistance itself. In this case, the output voltage, that is V out, will not be equal to zero because the source resistance is taking up part of the supply voltage. Now, coming to ideal sources of current. In an ideal current source, again, there are two things that we need to remember. First one is that the resistance is connected in parallel parallel to the current source. Second one is that the resistance in this case, the value of resistance, the magnitude of resistance is going to be infinity. Because if the resistance provided here is infinite, then there won't be any current flowing in this direction, and all the current will flow in this direction, and hence the I out or the output current that we get will be equal to the input or the source current. I out will be equal to Is when Rs is infinity. That is the case of an ideal current source. And if you draw a graph of current versus time, you can see that it is constant and completely parallel to the x-axis, which means that the current is not changing at any point of time, and all the current that is being produced from the source is going to output. In a practical current source, you can see that there is a loss in the current because the resistance, source resistance, is maximum and cannot be infinite. And hence, part of the current flows into Rs, which is why I out will not be equal to supply current. This is the comparison between practical current source and an ideal current source. And these are the ideal and practical current and voltage sources. Thank you very much.